Hi guys, this is Mrs. Mooney, and this video is about domain, range, and end behavior. Yes, I know this comic doesn't have anything to do with domain, range, and end behavior, but we've already learned about the numbers and I found it and I haven't got to use it yet, so I figured you would enjoy it. Alright, so first we're going to review representing an interval on a number line, which we covered yesterday, but just to go over it again, let's make a table. Alright, let's start with the number line. We've talked about this. If I had this representation here with a -5, I've got a closed circle on my -5, and I have a 7 with an open circle, and everything shaded in between. The inequality that would correspond to that would be -5 is less than or equal to, because it has that closed circle, and then x, and then less than but not equal to, because it has an open circle, and then 7. And then set notation, which actually I'm going to clarify for you today. Set notation is this fancy looking notation. It's got a brace, and then it has the variable, so in this case we'll say x, and then there's a bar, and that bar means given. And then you just put your inequality. -5 is less than or equal to x is less than 7. So it's just a fancier way of writing an inequality inside a set. So that set reads x given, -5 is less than or equal to x is less than 7. And then interval notation is what we talked about yesterday, where when it's included, so the -5 is included, we would put a hard bracket, and then we would put the -5, and then we would put a comma, and then we put the higher bound, the 7, and then it's not included, so we have a parenthesis. And you can write that note for yourself if you still need to remember included is in brackets, and non-included is in parentheses. Included has a closed, and non-included has an open. Sorry, that's messy, but this stylus is hard to write with, I guess. Alright, let's do another one of these. We'll put a number line. Okay, here we go. We've got a closed circle on a 2, shaded, and then to the right, and then the arrow is shaded as well. So that in an inequality form would be 2 is less than or equal to x. And then you might say less than or equal to infinity, but you don't have to. So the way to write this is just x is greater than or equal to 2. So in set notation, we would put the fancy bracket, and we're dealing with x's, given that x is greater than or equal to 2. And in interval notation, our lower bound is the 2, and it does include the 2, and our upper bound is the infinity. And remember, we don't ever include infinity because it's not actually a value, and we put a soft bracket on that. Which means I shouldn't have put this little line here, for those of you who are paying attention. Okay, let's move on to domain and range. We need to define these two things. So domain then would be the set of all input values, or the independent variable. Basically your x's, but it's not always x. It just depends on what your problem is dealing with, and that's always plotted on the horizontal axis. And the range then is the set of all output values, or the dependent variable, and that's always plotted on the vertical axis. So here you see a picture of a home on the range. Okay, I know, my jokes are bad, sorry. Alright, for this example, I've given you a graph, and I want you to state the domain and range of this function in inequality, set, and interval notations. And you will need to know the difference between those three, because you will be asked one or the other, and you need to know which one they are. But we'll do them all right now. So let's do the domain. And if you look at our x's, there are little arrows here, and remember, arrows mean it goes on forever. So negative infinity is our left bound, and positive infinity is our right bound. So our domain, if we were to do an inequality, we would have to say negative infinity is less than x is less than infinity. If we were to do set notation, we would need to write it in a pretty solution set. X's given that negative infinity is less than x is less than infinity. And something else that you might see, which you can do this, I'll let you do this, is you might see x given, and then you see this r with 2 lines on it. It has to have the 2 lines on it, but that line means, that r means all real numbers. So you can write your set notation with the fancy r. Alright, and then interval notation would be negative infinity to infinity, and this is the way I prefer to write it. It's the cleanest and easiest. For our range, we are looking at the y values now, and on the y-axis here, if you look, there is no graph below y equals 0. Our lowest y value is 0. And then the function does touch 0, so we're going to say less than or equal to, and then y. You can say less than or equal to infinity if you want to, or just y is greater than or equal to 0. So in set notation, we would put the brace, and then we would say all the y's given that y is greater than or equal to 0. And in interval notation, the 0 is the lowest y can be, so it comes first. Infinity is the highest y can be, so it goes second. We touch the 0, so we have a hard bracket on that, and we never actually touch an infinity, so a soft bracket on that. And another one of my favorite hilarious jokes. Okay, here's another function that I want the domain and range for. This time it's a linear, and because I can't tell exactly where that begins and ends, I put the function up here with it. We will assume that we are starting right here at -2. So for my domain, we start at -2, and then we're not touching it because there's an open circle on there, so less than x. And then on the far right here, we'll assume we end at 6, so less than 6. Once again, an open circle. If we were going to write it in set notation, we would want to say fancy bracket, x given -2 is less than x is less than 6. And if we wanted it in interval notation, which is my favorite notation, we would have a soft bracket -2, comma 6. Remember, least to greatest every single time. Now the range, because I've given you the function, you can't just assume that it's 2.5. You need to actually plug in, because we're looking at the lowest y value right here. We're going to plug in a 6. -0.4 times 6 plus 5 is going to give us 2.6. So now we know, okay, 2.6 is the lowest y value, is less than y, is less than, and then I can plug in the -2 for the highest y value. So -0.4 times 2 plus 5 gives us 5.8. So 5.8. Alright, then if we're going to do it in set notation, all the y's given, 2.6 is less than y is less than 5.8. And interval notation, 2.6, comma, 5.8, soft brackets on both of those. And here's a fun example. Now I'm going to give you a domain and range, and I want you to sketch a graph of a function that has that given domain and range. So let's start with putting our x and y axes on here. And then let's look at our domain. It says -3 to 7, and there's a soft bracket on the -3. So if I look at -3, that's right here. I'm going to draw a dashed line, because that's going to tell me that that is the leftmost I can go, and I'm not actually going to touch it. And then at 7, here, it's a hard bracket, so I'm going to put a little solid line. And this is just guidelines for me. This isn't my actual graph. That's why I'm doing it in like a highlighter color. The range is -5 to 6, and those are both hard brackets. So on y is -5, I'll put a borderline here, so that's the lowest I can go, but I do need to touch that. And then at y is 6, that's the highest I can go. So if you notice, I've created an area where my graph has to live. You can get a highlighter and shade that in, and it helps you see. You don't need to, but it helps. How cute. Okay, so I have this yellow box. Now I have to draw some kind of a function, and it doesn't have to be a linear. It can be curvy. It could be any kind of function you want, as long as it does, as long as it passes that vertical line test, in this yellow section. Now I know my left side here, I can't actually touch it, and that means I need an open circle anywhere on this left side that I want. Better, much better. It can be anywhere from here to here on this left border here. You can draw an open circle. Then we need a function, and we need it to go all the way up to the top or the bottom. I'm just going to go to the top and make sure it touches. And it also has to go to the bottom, and I have to make sure it touches. And it also has to go to this side and make sure it touches. And this is just one example of what you could do. You could do tons of different things. You just have to make sure that you touch the 3 parts that need to be touched, and you open circle it on the part that you don't want to touch. And then you have something between it, everywhere in between. You could go down, up. You could do whatever you wanted as long as you touch and touch and touch. Okay, the last thing we want to talk about is the end behavior of a function. And the end behavior of a function is, it describes what happens to the f of x values, your y values or your dependent values, whatever you want to call them, as the x values or the independent values decrease or increase without bound. Decrease or increase. So here we have another parabola graphed. And if I'm talking about the end behavior, I'm talking about what is it doing on the ends, obviously. And so here's how you would write it. For end behavior, you're always going to say as x, and then you draw this arrow, which means approaches, positive infinity, comma, f of x approaches, and then you look at it. As the x's are going this way, the y's are going this way, aren't they? Because it's going right and down at the same time. So f of x approaches negative infinity. As x goes to the right, y goes down, is essentially what that's saying, but you have to write it like this. Then you also have to give me the left end. As x approaches negative infinity, the function, or the y values of the function, approach. And so now as x is going this way, it's also going down. See, it's going left and down too. So f of x approaches negative infinity. So here's another example. This is a function that you'll learn about later this year. It's approaching what we call an asymptote here. So when we talk about our end behavior now, we're going to say as x approaches positive infinity, the function f of x approaches, and if you look at it, as x is going to the right, y is going up, see? So f of x approaches infinity. As x approaches negative infinity, f of x approaches, and then look, as x is going to the left, the y value is getting closer and closer, but will never cross this line at 0. So the y is approaching 0. And so you'll see that whenever we have things like asymptotes, where the y value is not approaching a positive or a negative infinity, but it's actually approaching a specific value. And just make sure that you learn to write it like these, because that is how it's going to be written on your test. The end. See you tomorrow.